बाद अब हम देखेंगे सब्ट्रैक्शन का प्रोग्राम। ओके, मैंने लोड किया है ये, ठीक है। 8 बिट डेसिमल सब्ट्रैक्शन है ये वैसे तो, ठीक है, बट 8 बिट हम फिलहाल के लिए वो करेंगे। 8 बिट डेसिमल सब्ट्रैक्शन, 8 बिट डिवीजन, 8 बिट मल्टीप्लाई, 2's complement of an 8 बिट नंबर, और ठीक है, जैसे सपोज नाउ डू यू नो कि आपका सब्ट्रैक्शन आप किस तरह से करते थे। वैसे अगर इसमें देखा जाए तो मैंने आपको पहले बताया था, जैसे कि 8 बिट एडिशन का प्रोग्राम था। this was your 8 bit addition program. Okay, in this program you just have to change this instruction, this one line of instruction with SUBM, and you will automatically get your subtraction program. Okay, that program will subtract two 8 bit numbers, है ना? But you have to make sure, I have already told you, you have to make sure in that case your first number is always greater than the second one. Now if you see in this case your first number is less than your second number. Okay, so now if you subtract these numbers, it will not show any borrows which are which ought to be taken by this program. Okay, if this program takes matlab any borrows to subtract those two numbers, those will be not right here. That was the problem, that program action. But another method to subtract two 8-bit numbers is your 2's complement method. Okay, so first we will look at this 2's complement method. What is this 2's complement method? And you must have studied this in your previous class, no? You have studied it in your digital class, 2's complement method of subtraction. But 2's complement method पढ़ा है? कैसे होता है 2's complement? Okay. So can you tell me the standard procedure to convert convert a binary number to its 2's complement representation? First of all, what do you do? What is the first step in converting a number to its 2's complement representation? What is the first step?
1 का कॉम्प्लीमेंट
First
करके
step is
8
always
प्लस कर दो।
complementing 8 1 का complement करके और every bit का। One complement. What is one complement? How? अच्छा, okay. One. You are talking about one's complement, no? Okay. So how do you do that? By complementing each individual bit. है ना? Suppose you have a number. Suppose you have a number. Suppose you have a number 10010 101. Sorry. First step will be complementing it. No. How that complement is represented? 0 1 0 0. Is this okay? Okay, and then what you will do, add 1 to the least significant bit of your binary number, है ना? Okay, so your is your will be 0 1 0 1 1. Is it okay? Is it okay?
Yes, sir.
Okay. So if you have a number, suppose again 1010 is your number. First you have to do 0101 and then you add 1. That means this answer will be 0 1 0 0 0 1. You add this, what you will get? 1 plus 1 is 0. Next you will get 1. So you will get 0 1 1 0. Is okay?
Yes, sir.
You're not getting anything? Can you see? Okay. दिख रहा है? Okay, can you see this? What I have done is I have taken a number 1010. First step is to do your ones complement. In ones complement, what you will do? You will complement each individual bit of that number. Okay. After complementing, you will add 1 to the whole number. The result you get is the 2's complement representation of this number, है ना? 1010. Okay. You get it now?
Yes, sir.
Okay. So this is the 2's complement representation. Now suppose you have to subtract two numbers. Suppose I will take a simple example first. Suppose it is 5 minus 3. Now what you will do? You will keep your 5 as it is, 0 0 1 1 0. Is it okay? This is the representation for 5. Okay. But you will take the 2's complement of 3 because
1010.
is it 6? Sorry, 0 1 0 1. Okay, sorry. Okay, this is the binary representation of 5. Okay, and to represent this number, this is minus 3. Okay, or we can write it as 5 plus minus 3. Now what we have to do is we have to represent this number. Okay, minus 3. How we will represent it? We will convert it into its 2's complement representation. That will be the representation of minus 3. Okay, then we will add that number to this 5. Okay, and we will get our result. We'll see how. Suppose this is your 3. So first, what we'll do? We will represent this 3 in its normal form. What is the normal form? 0 0 1 1. This is the representation of 3. Okay. 0 0 1 1. This is the representation of 3. Now complement every bit. We will get 1 1 0 0. You get 1 1 0 0. Now add 1. Adding 1 will give you 1 1 0 1. This is the 2's complement representation of 3. Okay, and it represents your minus 3. Okay, now we will add this 1 1 0 1. What? After complementing, you got this. इतने तक clear है? Now add 1. What you will get? 1 1 0 1. Add 1 to this, no? How? Suppose I'm adding 0 0 0 1. I'm adding this number, no? Now 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1. Is okay? Okay. Now add these two. Adding these two will give you what they will give you. 1 plus 1 is 0. Okay, 0. 0 comes here. Carry is go forward. Okay. So 1 plus 0 is again 1. Here 1 plus 1 is 0 again. And you will get 1 here, and 1 plus 1 is 0 again. So the only one you will get here is here. Okay. And 1 plus 1 is again 0. And the carry which is generated, that will be discarded. So you will get your answer 0, 0, 1, 0. You got this addition part?
Yes, sir.
You got this addition part? How? 1 plus 1 is 0. Carry goes here. Carry goes here. This. Now 1 plus 0 is 1 again. That is okay. 1 plus 1 is 0. And 1 carry goes here. 1 carry goes here. Now 1 plus 1 is again 1 plus 1 plus 0 is again 0, and 1 carry will be generated. And what you have to do with this that carry, you will discard it. Okay, that carry is discarded. Okay, so you got your answer 0, 0, 1, 0, which is 2. And 5 minus 3 is also 2. Okay, you got it? You got it? Okay. Now tell me. Now we will look at the program part. Now, okay, LDA C050. LDA C050. Now, what it is doing is, it is loading the accumulator with the contents of C050. Okay, C050, what is the data stored in C050? It is 96H. ये आपकी initiation है, ठीक है? These initiations are limited to your simulator, your online simulator. Okay. Okay. If you were doing this experiment on your hardware kit, these type of initiations are not required. Okay. So first thing is loading your accumulator with your data. So loading your accumulator with the contents placed in C050. Okay. Next step is complementing each bit. This is CMA, complement the accumulator. Complementing accumulator means it will change the state of each bit, like this. 1010 will be changed to 0101. 1 will be changed to 0, 0 will be changed to 1. That is the complement operation. So complement the accumulator. Okay. After complementing, what it will do? It will increment it by 1. Increment or add. You will do the same thing. Okay. Can you tell me what other instruction can you can use here? What other instruction you can use here? MVI? How MVI? Not MVI, no. You have to increment it by 1, or you can add 1 in it. So what you will use? You will use some arithmetic instruction. You will use some arithmetic instruction. What other instruction you can use? Are you seeing here? ADI 8-bit data. Add immediate to the accumulator. So what you can do here? You can use ADI 8-bit data, and that 8-bit data will be 0, 0. What I was adding to get the 2's complement number, 2's complement representation. How much we were adding?
1.
1. So what I will write here? ADI
0, 1.
0, 0, 1. Okay. I can use this instruction instead of this. But can you tell me what is the disadvantage of using this instruction? Yes, this is a 2 byte instruction. Okay, this is a 2 byte instruction, and INRA is a make it 1 byte instruction. So this is the more optimized way to use it. Okay. Okay. So this is the more optimized way to write your code. This instruction is more optimized than this because this will consume less memory. Okay, instead of this. Otherwise, you can use this ADI 8-bit data. Okay. And if you want to add any other number than 0, 1, then you will use this command itself. Okay, you just have to add 1. So that's why we are using increment A, because it will increment this accumulator, contents of this accumulator by 1. If you have to add some other number other than 1, some number other than 1 or greater than 1, what you will use? You will use ADI. In that case, you will not use INRA. Okay. So after adding the 1 or incrementing the accumulator by 1, is storing the result in the second memory location C051. And after that, halt. Okay. This is the method of your 2's complement. Now, can you tell me what is how you can subtract 2 numbers by using this 2's complement method? How can you subtract? Can you tell me? Now this is very simple. First step will always be first step क्या होगा हमेशा? Loading your data. क्या यही होगा? To know it is required to. Okay. Now what you will do? Suppose you have to subtract two numbers, no? 5 and 3. 0, 5 and 0, 3. You have to subtract 2 numbers. Your first step will always be LDA C0 50. Okay. Okay. Now I'm using 2 numbers. I'm using 2 numbers in which to C05 will C051 C050 contains your first number. Suppose it is 05, and C051 contains your second digit, and suppose it is 03. I'm taking simple example first so that you can understand. Okay. And we will store the result in the third memory location C053. Okay. This is reserved for a result. Okay. Now first step will be loading the data. When as soon as you load your first data, you loaded it in accumulator directly. It is loaded in accumulator directly. Now next step will be now what you will do?
सेकंड डेटा वो लोड करेंगे.
Now I will do 2's complement. Yeah, you have to move the second data, no? I have to move it somewhere. So what I can do? Hmm? What will I do? Tell me. अब आ रही है? Hello. Hello. आ रही है? Okay, let me disconnect.
Can you hear me now?
Yes, sir.
Okay. Now your first number is moved to accumulator. Now can you tell me where the number?
HL रजिस्टर पेयर में.
HL register pair. HL register pair. Should I move it to HL register pair? Where should I move? Now, first, let me tell you this the algorithm which you will follow. Okay? Your first step will be, what will be your step 1? Load first number to a register. Okay. Your step 2 will be load second number to a register. Okay. Now register can be anything from accumulator to your all other register pairs B, C, D, E, R, H, L. Okay. Same goes here. Accumulator B, C, D, E, or H, L. All those registers. Okay. Now what you will do? Now you know which number is which. Okay. If you have loaded 5 in the accumulator and 3 in some other memory in some other register, now what you have to do, you have to do the twos, you have to apply twos complement method to that number 3, because that is the smaller one, that is the smaller number. And okay, so we have to complement that. So in whichever register it is, step 3 will be, your step 3 will be to complement the bits of the smaller number. Okay. Now step 4 will be to add or to increment after complementing. You have to increment that number by 1. After that, step 5 will be to add the result of 2's complement with other number. Okay, and your step 6 will be store the result. Is it clear to you? ये सभी को clear है?
Yes, sir.
Okay. Now what you will do? Okay. Now what you will do? Move the second number to accumulator. do this. Move the second number, because in addition, your sequence doesn't matter. Okay, in addition, your sequence doesn't matter. Okay, if you are adding 5 plus 3, if 3 is ahead, it doesn't matter. But in subtraction, it matters. Okay, so that is one advantage of your 2's complement method, that it converts your subtraction operation into an addition operation. Okay, so you don't have to bother about your sequence. You can load the second number into accumulator. Okay, what you will do, load the second number into accumulator and load the first number into some other register, C, B, C, D, or HL. You can use any one of that. Okay, load the second number to your accumulator, then apply this complements method. Use complement method. Once you have applied this, okay, after applying this, what you will do, you will come to step 5. Then you just have to use one instruction of add the contents of accumulator to the contents of the register in which you have stored your first number. That will be your 05 in this case. I've taken the example of 05 and 03. Okay, and after that, what you have to do is you have to store the contents of your accumulator in some memory location. Okay, do you understand?
Yes, sir.
Okay, so after moving, you can use this command LDA C050. After using this, you can move. What you have to do is you have to move the contents of accumulator. Move the contents of accumulator to which location? Whichever location you want. Okay, data. You can see these instructions, data transfer instruction. Okay, what you can do is you are using move instruction, MOV. Okay, so you can use this. Okay, so this is your move instruction, MOV, RD, RS, MRS, RDM. Okay, if any register you want to move from one register to another register, you can use this. Okay, and instead of using LDA, you can also use LXI. That is up to you. So you can use first use LXI C050, LXI HC050. Then you can move the contents of that register to some other memory location. Then you can also use LXI and you can also use LDA in the same program. But you have to optimize your code. So you must be careful about using those instructions in your program. Okay. Do you understand this? Can you do this? आप ही कर सकते हैं कि should I show you? You have any problem? आपको कहीं प्रॉब्लम है? पहले tell me that thing if you have any problem. Then first try. Okay, if you face any problem, then I will tell. What I told you, मैंने आपको क्या बताया अभी? मैंने आपको अभी क्या बताया? Okay, okay. Now यहाँ पे I can tell that, यहाँ पे मैं क्या बता सकता हूँ आपको कि यहाँ पे LXI यूज करना is more sensible than your LDA. Can you tell me how? Can you tell me how? कौन से registers में? वो तो उससे भी हो
सर,
रहा था, LDA से भी हो रहा था.
सर मूव का यूज नहीं करना पड़ेगा.
मूव का यूज बाइट्स कम कैसे लगेंगी? हाउ? लुक, यहाँ पे हम सिर्फ कॉम्प्लीमेंट कर रहे हैं. दिस इज नॉट द प्रोग्राम फॉर योर टूज कॉम्प्लीमेंट सब्ट्रैक्शन, है ना? यहाँ पे सिर्फ कितना डाटा यूज हो रहा है? हाउ मच डाटा इज देयर? सिर्फ एक डाटा है ना यहाँ पे, है ना? ओके, नाउ टेल मी, अगर यहाँ पे 2 डाटा हो और मैं फिर LDA यूज करूँ, वो ऑप्टिमम है या यूज करना मतलब डिसएडवांटेजेस रहेगा? इफ देर इज मतलब आपके पास डेटा जो है मोर देन 1 है, मतलब मोर देन 1 डेटा है, देर इज 2 और 3 और 4 नंबर ऑफ डेटा, मतलब नंबर ऑफ डेटा जो है आपका एक से ज़्यादा है, इन दैट केस LDA यूज करना ठीक रहेगा? बिकॉज बिकॉज LDA से आपका डाटा जो है वो डायरेक्टली एक्यूमुलेटर में चला जाएगा, है ना? अगर आपको 2-3 नंबर लोड करने हैं तो आपको दोबारा से फिर LDA यूज करना पड़ेगा, है ना? बट इन दिस केस मैं क्या कर सकता हूँ, अगर मैंने एक एड्रेस जो है HL पेयर में लोड कर लिया, देन आई कैन easily increment it and then access the data. Do you agree or not? In the case of LDA, you cannot use your increment command. Okay, so let me show you. LXIH, you have done LXIH C050, है ना? Then move that. I'm moving it to C. From where? From memory. Okay, move the data from memory, which is in C050 to your register C. So I've moved the first data into C. I moved the first data into C. Okay. Now what I have to do is I have to just increment I NX H. Do you agree?
Yes, sir.
Do you agree? Do you agree? है ना? ठीक है. INX H कर लिया, उसके बाद मेरे को क्या करना पड़ेगा? वो डाटा मेरे को कहाँ मूव करना पड़ेगा? Accumulator. So what I will use, move again, move A M. Do you agree? Now the same program will go on. Now the 3 has been moved to your accumulator. Okay, now you will complement it, you will increment it. Okay, now before storing it to some other location, what you will do, you will add the contents of A and C, है ना? So what I will use, add A to C. Okay, and store the accumulator to C052. Do you agree? And your first data will be 05 and second data will be 0 T. Is this okay?
Yes, sir.
Now, do you think this is the right code, or do we have any mistake? Do you understand this? You understand this, no? Okay. Now I will use the autocorrect operation. It will automatically adjust the indents if there is any incorrections in your indent or something, or comma or something like that. It will auto correct it. Okay. But your add command has been removed. Can I use this add? Is this okay?
सर सिर्फ ऐड सी होगा.
सिर्फ add C होगा.
यस सर.
मतलब
सर ऐड का मतलब यही होता है कि ऐड द कंटेंट ऑफ एक्यूमुलेटर विद गिवन रजिस्टर.
okay, but okay. Is it okay now?
यस सर.
No, I'm not okay. Is it okay? Now we will assemble it. Now I will run it all time. You can see the result. Okay. Can you see this? Is it all right?
यस सर.
Okay. So the result of subtraction of your 0, 5 and 0, 3 is 0, 2. This is okay. Now can you tell me if this code can be optimized or not? You can optimize it in some way, or think for about a moment. Think for a moment, then tell me if you think this code can be further optimized. Hmm? Now if I see this, sorry, if I see this, it is using memory till here. It's from 0000 to 000C. If I do this, suppose I load LXIHC051. Okay. Then I move that. Okay, I have told you earlier, you have to be careful about these indents. Okay, these may sometime give you some error. Okay, so be aware of that. Then I will use. Okay. Now what I have done is LXIH C051. Move the contents of memory to your accumulator, and now rather than incrementing it, I will increment it. DCX. Run command. DCX. Logical. Branching. Arithmetic. Data. Increment. INX, DCX. register pair by 1, na? DCX. Okay. Now if I do this, I have loaded HL pair with C05 pin, move the contents A, then decremented HL pair. Okay. Then complemented the accumulator, incremented, and now I will add this to N. Okay. Now if I assemble this, can you point out error in this? If there is some error in it, am I using it at right place?
सर INR A के बाद डिक्रीमेंट करेंगे.
Okay. Let us check this. I was also thinking about this. Command X. Now if we assemble it, run all at one time. Now, and you see, we have optimized our code. When we have reduced, we are able to reduce one memory location. Earlier, one extra memory location was used, but now we are able to reduce it by 1. So this is more optimized. Can you see this?
Yes, sir.
Okay. So ये आपको समझ में आया? Do you understand this? If you have any doubt, किसी को इसमें कोई डाउट है तो प्लीज आस्क. ओके.
सर इसको असेंबल एक बार करके दिखाइए.
हाँ जी.
इसको सर एक बार असेंबल करके दिखाइए.
सॉरी आई कांट हियर यू. क्या बोल रहे हो आप?
सर हम ये कह रहे हैं कि जैसे कोई भी इंस्ट्रक्शन है सर, जैसे ऑप कोड या एक्स कोड जनरेट, तो वो सिस्टम जनरेटेड होता है या मैनुअली उसको जनरेट कर, मतलब फाइंड करने कोई तरीका होता है?
नहीं, वो फिक्स्ड है. वो फिक्स्ड है. दैट इज फिक्स्ड. वो क्या है, वो आपका मतलब प्रोसेसर को बताने के लिए है कि ये इंस्ट्रक्शन फीड हो चुकी है, इसलिए वो जो है वो मतलब पहले से ही वो किए हुए हैं, फिक्स किए हुए हैं. ओके.
तो मतलब सर वो सिस्टम जनरेटेड है.
ये एक तरह का कोड है उनको रिप्रेजेंट करने के लिए. ओके. the moment you feed this LXIH, जब मैं इसको असेंबल करता हूँ, you see LXIH हमेशा आपको दिखेगा कि LXIH जो है हमेशा आपका 21 से रिप्रेजेंट होगा. तो दिस इज फिक्स्ड. जब भी मैं 21 फीड करूंगा, then it will automatically know that I have fed the LXIH command to it. ओके. और ये एंड कहाँ पे होगा, ये कैसे पता चलता है? ये इसको पता चलता है बाय जैसे हमने टाइप्स पढ़े थे, 1 टाइप, 1 बाइट, 2 बाइट और 3 बाइट इंस्ट्रक्शंस. उसको इस चीज से पता चलता है कि ये इंस्ट्रक्शन कहाँ पे खत्म होने वाली है. नाउ यू सी LXIH अगर मैं फीड कर रहा हूँ, अगर यहाँ पे 21 आया फर्स्ट हैंड, नाउ इट विल अंडरस्टैंड आई हैव फेड इट LXIH कमांड. ठीक है. और ये 2 बाइट और एक्स्ट्रा कंज्यूम करेगी, तो इट विल रिजर्व 2 बाइट्स एक्स्ट्रा फॉर इट. और जब ये 3 बाइट्स पूरे हो जाएंगे, देन इट विल सॉर्ट आउट द नेक्स्ट इंस्ट्रक्शन. तब इसको नेक्स्ट इंस्ट्रक्शन चाहिए होगा. सो after we introduce 7e, now it will know I have typed the move am command. Okay, मैंने feed किया है move am command and it is 1 byte. So after consuming 1 byte, it will move to next instruction. That's how it will know that is it 1 byte instruction, 2 byte instruction, 3 byte, or which type of instruction is this. ये LXI है, move है, CMA है, INR है, DCX है, वो सारे ये देखो हमेशा जब भी आप यूज करोगे move am के लिए 7e ही यूज होगा, CMA के लिए 2FE यूज होगा, INRA के लिए 3C ही यूज होगा. These are fixed. जब भी आप ये फीड करोगे द प्रोसेसर विल ऑटोमेटिकली नो कि आपने कौन सा कमांड यहाँ पे उसको दिया है. ओके यही डाउट था आपका.
यस सर.
क्वेरी.
यस सर. सर जैसे LXI के बाद उसमें एड्रेस लिखा है, अगर एड्रेस चेंज कर दें उसका थोड़ा सा, तब वो ऑपकोड वही रहेगा या चेंज हो जाएगा?
कहाँ पे
सर जैसे लिखा है LXI XCO 51, यहाँ पे हम कुछ और कर दें. ये
हाँ, यहाँ पे
3051.
अगर आप कुछ और कर रहे हो यू कैन यूज एनी अदर. अगर यहाँ पे कुछ और यूज कर रहे हो आपको यहाँ पे सिग्निफाई करना पड़ेगा. यहाँ पे
तब
मैं
उस समय
C050.
चेंज हो जाएगा.
हाँ,
तब उस समय हेक्स कोड चेंज हो जाएगा अगर हम चेंज कर देंगे.
हेक्स कोड नहीं चेंज होगा. नाउ यहाँ पे नोट कीजिए, ठीक है, नोट दिस. यहाँ पे असेंबलर में ले गया मैं, LXIH के लिए क्या कोड है 21, मूव AM के लिए क्या कोड है 7E. इन दो को याद रखना बस, ठीक है. रिमेंबर दीज 2 कोड्स, ये कभी भी चेंज नहीं होंगे. यहाँ पे अगर आप एड्रेस चेंज भी कर दो, इफ यू चेंज दिस एड्रेस और डेटा फॉर दैट मैटर, सपोज आई यूज 200H यहाँ पे, ठीक है. और यहाँ पे भी मेरे को चेंज करना पड़ेगा 2001. यहाँ पे मैं कर दूंगा 2002. ओके, इफ नाउ फर्स्ट आई ऑटो करेक्ट इट, देन आई असेंबल इट. नाउ यू सी LXIH का हमेशा कमांड इसका क्या है, हेक्स कोड क्या रहेगा 21, मूव AM का क्या है 7E. बट यू कैन सी हियर यहाँ पे जो एड्रेस है ये चेंज हो गया है 2001. नाउ द एड्रेस इज 2001. ओके, इफ आई रन इट बाय वन टाइम, नाउ यू कैन सी यहाँ पे एड्रेसेस चेंज हो गए हैं. यहाँ पे आपका स्टार्टिंग एड्रेस जो था वो 2000 था, 2001 था और 2002 आपका जहाँ पे आपका रिजल्ट स्टोर हुआ. बस ये 3 लोकेशंस आपकी चेंज हुई हैं, रेस्ट ऑफ द लोकेशंस आर सेम. ओके, यहाँ पे और यहाँ पे आप ये सिग्निफाई यहाँ पे आप वो कर सकते हो, चेंज कर सकते हो, ठीक है. बट यहाँ पे देखो यू कैन सी हियर, यहाँ पे LXIH का जो हेक्स कोड है या ऑप कोड है वो चेंज नहीं हुआ है. 7 ही सेम है, 2F सेम है, 3C सेम है, ये सारे सेम. ओके, सिर्फ यहाँ पे ये चीज़ चेंज हो रही है. दैट्स वाई आई हैव ऑलरेडी टोल्ड यू, दैट्स वाई दीज आर 3 बाइट इंस्ट्रक्शन. क्योंकि इन 2 बाइट्स, ये 2 बाइट्स जो है वेरिएबल हैं, यहाँ पे चेंज हो सकती हैं, तो हर टाइम इनको स्टोर करने के लिए 2 बाइट्स एक्स्ट्रा चाहिए होती है. दैट्स वाई दीज आर 3 बाइट इंस्ट्रक्शंस. अगर यहाँ पे ये फिक्स हो जाए INRA, सपोज ये फिक्स है कमांड, यहाँ पे कुछ चेंज नहीं हो रहा है, तो यहाँ पे हम इसको सिर्फ 1 बाइट से रिप्रेजेंट कर सकते हैं और ये हमेशा फिक्स रहेगा. मतलब INRA का जो हेक्स कोड है हमेशा 3C यूज होगा. और जब भी आप 3C फीड करोगे, ये जब भी 3C फीड करेगा आपके 8085 माइक्रो प्रोसेसर को, इट विल ऑटोमेटिकली नो कि आपने कौन सी कमांड फीड की है INRA. इज इट ओके?
यस सर.
ठीक है. एनी अदर डाउट? ओके, तो मैम